So today is all about applications, word problems. I know that for most of you guys, these are your favorite types of problems. Just kidding. For none of you, they are. I don't like word problems either. I'll go ahead and say that right off the bat. If you give me a bunch of numbers, I'm just super happy. But if you bring reality into it, it bothers me for some reason. But that's no reason not to learn the word problems, right? If you want to make money doing this stuff someday, these are the kind of things that you're going to have to put into place. You're going to have to learn. So for the very first one, and I'm trying to do something slightly new. Just so you guys know, if you come back and watch these videos later, I'm trying to make these descriptions on the side here be a little bit more descriptive. And that way, when you go back and you watch the video, if you are wanting to know kind of like, if you're stuck on an area of a triangle problem and you want to know exactly where in the video we worked on that, you can follow this little highlighter down to that square, okay? And so it'll help you kind of like sift through the videos without having to listen to me blab too much. And you can see at the bottom, that's just what I wrote on the bottom one, I guess. It tried to interpret all this stuff. All right, so the very first problem we're going to work on is consecutive numbers. This is pretty familiar because we did a consecutive numbers problem back when we were adding things. The difference here is now we're multiplying things. So this problem says that we have consecutive racing numbers assigned to boats. The product of these two numbers was 156. Find the numbers. So when we talk about consecutive numbers, we can say, let the first number be represented by n, right? Then we know that the second number can be represented by n plus 1. So this says that the product of those two numbers is 156, which means n times n plus 1 equals 156. All right, so now that we have our equation, we go ahead and we solve it, and the problem should be done. So to solve this equation, I'm dealing with a polynomial. And so remember, a polynomial, before we solve it, we have to set it equal to 0. This is set equal to 156, which is not 0. So we need to basically multiply everything out and then collect it to one side and refactor it, okay? So I'm going to distribute my n in here, and that gives me n squared plus n equals 156. Now I want to set it all equal to 0, so I'm going to subtract 156 from both sides. Minus 156, minus 156. This side they cancel, and on my other side I have n squared plus n minus 156 equals 0. Now that I have my whole polynomial equal to 0, I can go ahead and factor it and use those factors to solve. So I don't have a coefficient here, so this is kind of a simple factoring. I'm dealing with the variable n, so that's what goes in the first term of each binomial. And now I take a look at the numbers I'm dealing with. So I have a negative term here, which means one of these is positive, one of these is negative. And what I'm looking for, since this is a negative, I'll be looking for a difference of factors. I'm looking for two factors of 156 that differ by the coefficient of the middle term, 1. What do you guys think? Not quite, right? 156. What is 156 divisible by? You shot out of the gate a little quick there. Ah! Oh, no, I lost it. That was awesome.
73.
73?
I think.
Okay, 156
No, that was 80 something.
divided by 73. You realize you're going in the wrong direction, right? Okay, so let's just, I don't know, let's start out with 12. 156 divided by 12. That's usually 13. 12 times 13 equals 156. That's how you handle that, though, when you're not sure what two numbers. Just start plugging them in your calculator, right? The longest it's going to take you is maybe a couple minutes at the most. So yeah, if you're not sure, just start guessing and checking on the calculator, and eventually you can find those. So I have 12 times 13, that equals 156. I want these to sum to a positive 1, because that's what my middle term is. So which one of these should go on the positive? Good. And there we go. So now the last step of this is still equal to 0. The last step of this is I need to come up with a solution for each one of the factors that I just found. So I solve this first factor for 0. I say what value of n would make n plus 13 equal to 0. If I subtract 13 from both sides, I see that that is n equals negative 13. All right, if I play the same game with this factor, if I say what value for n would render this entire factor equal to 0, I think we can kind of just see that it's n equals a positive 12. So now this is something that'll happen a lot with word problems. One of these answers doesn't necessarily make sense, right? We have negative 13. I don't know. I guess maybe it's possible, but who's gonna number their boat in negative 13? I don't think it is possible, right? They say these are racing numbers assigned to boats. So we cross that out as a solution. We say that doesn't make sense as a solution. So the answer must be this one, n equals 12. So I go back up to my original problem, and I say, they say find the numbers, and so I would say the first number is 12. The second is 13. All right, so that is a consecutive numbers problem. The next one, this is a problem to deal with the dimensions of a rectangle. Excuse me. So Wooden Work Limited builds cutting boards that are twice as long as they are wide. The most popular board that Wooden Work makes has an area of 800 centimeters square. What are the dimensions of this board? Okay. So these guys make a cutting board. Whoa. These guys make a cutting board. I was. Not making cutting boards, though. So these guys make a cutting board, right? We have length and we have width. The area of this cutting board is L times W. So they say these cutting boards are twice as long as they are wide. Not L squared, right? So what we have to do before we plug stuff into this formula, L times W equals A, is we have to solve one of these in terms of the other, so that when we get into the overall problem, we only have one variable that we're dealing with. So if they say that these boards are twice as long as they are wide, yeah, 2L equals W. Is that right?
Yeah.
Yeah, there we go. Okay, so we have a value for W, which means we're going to plug it directly in here. All right, so I have L. I'm going to start writing them like that so I don't confuse myself. I have L times W, which is going to be replaced by 2L now, equals my area A. And they said that my area was 800. Okay. So now once again we have a polynomial. We'll just do this multiplication on the left side real quick, and that gives us 2L squared equals 800. And now I have a quadratic, which means I have to set it equal to 0 and then factor everything out. So I'm going to go ahead and subtract 800 from both sides. That's going to give me 2L squared minus 800 equals 0. And now I need to factor this polynomial to get my solutions. What do you guys think should be the first step to factoring this polynomial? Quick. I'm hearing stuff.
What do we factor by 2?
Yeah, factor out a common term first, right? Remember, when we factor stuff out, always think about a common term that could come out first. And that typically makes things easier for you later on. So we factor out a 2, which leaves us with an L squared minus 400. And that is equal to 0. This kind of looks like a difference of squares, because the first term is squared. I'm just not sure if the last term has an even square root. So I'm just going to plug it in here and check real quick. So square root of 400, that's equal to 20. So I use my difference of squares formula on this. Remember, difference of squares says a squared minus b squared is equal to a plus b, a minus b. All right, so this one here simplifies into 2 times L plus 20 times L minus 20. And that all equals 0. Now that I've factored everything, I evaluate each factor to see if there's a way that that factor can equal 0. This first factor, there's no solution that comes out of that. There's no way that 2 is ever equal to 0. Since there's no variable, no solution from that one. The second factor here, L plus 20. We ask ourselves, we say, well, what value of L would render that factor equal to 0? It's L equals negative 20, right? So that's one solution to this, because that would make this equation true. For this last factor, we play the same game. And it turns out if we plug in a positive 20 for L in that factor, we also get a 0. If you're wondering why I'm doing this part, go back to the last chapter that we went over. I think it was chapter, maybe it was 5.6. Go back through 5.6 and take a look at the zero product principle. That's how we're able to solve all these. Or look at yesterday's lecture. That's also one route you could go. Okay, so one of these answers does not make sense. Of course, the length is not going to be negative 20, so I have length equals 20. All right, and if my length equals 20, they wanted to know the full dimensions, so I would put this in a sentence if I was in a test, but I'm not, so I'm just going to write it on the side. I would say L equals 20, and they did say that the width was 2L, so we can say W is equal to 10, exactly. No, W is equal to 40.
Oh, it's 2L.
Yeah, because it's 2L equals W.
Oh.
Yeah. All right, so that is the dimensions problem. It's very similar to the dimensions of a triangle problem. So the dimensions of a triangle, it works the same way. We just use a different area formula, that's all. So the area formula for a triangle says 1/2 base times height. This is number 18 in the homework if you guys are looking for the problem. All right, so, and they say this 1/2 base times height for this tent opening, this is equal to 12 feet squared. All right, so all we need to do is sub in the appropriate values for base and height. So let's see, now right here on the diagram, right, they say the entrance is 2/3 as wide as it is tall. So they named the height H, and the width is 2/3 H. Okay, so that means that back in our formula, our base is equal to 2/3 H. All right, now that we have a value for B, we can plug it into that area formula. We can just plug it right in there. All right, so that leaves me with 1/2 times B, and we know that that's actually equal to 2/3 H. So I have 2/3 H, and then multiply that by H one last time. That's all equal to 12. All right, so we go ahead and I'll multiply the fractions together first. Well, I'll just multiply it all together. That gives us 2/6H squared equals 12. And of course, that's just 1/3 h squared equals 12. All right, so I have a quadratic. I know that I need to factor this to solve it, and first I need to set it equal to 0. So I subtract 12 from both sides. I end up with 1/3 h squared minus 12 equals 0. So this is a handy trick right here. You know, we don't like negatives in our leading term, and we also don't like fractions, right? Because who wants to guess and check with fractions? Not me. I'm guessing nobody. So what we do is we multiply everything through by something that will clear that fraction on the leading term, right? We're allowed to do this because this is an equation, and it's like a balance beam, right? So we can multiply both sides of this and not change the value. What number should I multiply by to clear this 1/3 fraction? 3/1, good. Multiply both sides by 3. That means I will have plain old h squared, because these two 3's will cancel, minus 36, aha, equals 0. What should I use on this? What do you guys think? How should I factor this guy? Does this look familiar? Are you guys starting to get the vision yet? We just used it. Difference of squares.
So h times, if we use two parentheses things,
Good, good,
h in each one,
good, good.
and a 6
A 6 in each one, good, good.
in each one.
And a plus and a minus, right? Yeah, so thanks for indulging me on that one, guys. Yeah, so I just want you to recognize, right, when there's two terms with a minus sign in the middle, always look to make sure they have squares, right? If they have even squares, you can use this each and every time. It's a great little trick. So now that we've reached this step, we've factored both of these, or we've factored this polynomial. This first factor, this tells us that one solution to this equation is h equals -6. This second factor, this tells us that one solution to this equation is h equals +6. If we go back up to the original problem, the problem's about area and length and things like that, so -6 is not really a valid solution. So we cross that one out. And we would go back up, and they say find the height and the base. So we would say h is equal to, what did I find it was? 6, that's right. 6. The base was equal to 2/3 h. 2/3 times 6, which gives us 4. So I had height of 6, base of 4. Right, so that's the dimensions of a triangle problem. You know, they'll talk about the area, and so you just have to remember this little formula, the 1/2 base times height. Once you sort of remember that, the rest kind of tends to fall into place. Okay, next. The medicine problem. So, this problem is all about medicine, which some people should be paying special attention right now. All right, so for certain people suffering an extreme allergic reaction, the drug epinephrine, aka adrenaline, is sometimes prescribed. The number of micrograms N, that is important, of epinephrine in an adult's bloodstream, T minutes, that is also important, after 250 micrograms have been injected, is shown on the table at the left. Don't worry about that table, we don't need it. For several values of t, and can be approximated by this polynomial. So they want to know how long after an injection will there be about 210 micrograms of epinephrine in the bloodstream. So the number they give us is 210. We have to make sure that we are plugging that in the right place, right? We have two different places we could plug it in, either t or n, right? We go back to the original problem. T was supposed to be the number of minutes, so we don't plug it in there. N is the initial number of micrograms of epinephrine. So yeah, we plug it in for n. So we have -10t squared plus 100t equals 210. All right. So now we just go about solving this, right? As you guys know, we want this set equal to 0. So we're going to subtract 210 from both sides. That's going to give us negative 10t squared plus 100t minus, minus 210. And that is now equal to 0. So the next step, because I don't like this negative sign here, and because there's common factors in all these terms, I'm going to factor something out first. I can definitely factor out a negative 10. I'm going to go ahead and do that. So I have negative 10 out front. I can't factor out any variables. So what I have left is t squared, right? Since I factored out a negative 10, all these signs have to change. So my 100t, that turns into a negative 10t. My negative 210, that changes into a positive 21. And that is still equal to 0. Okay, so now that we've factored out our common term, we go to work on this inner factorization. And actually, since you guys look sort of bored, oh, actually, never mind. This one's in the chapter. You guys don't want to figure this out by yourself. Forget about it. Okay, so the 10 drops straight down, right? And now we're going to solve for this particular polynomial, right? There's no coefficient, right? And so it's just t and t. Question? Okay. Oh, okay. Right? Isn't that nice when you first start seeing this and you realize that pattern is not too bad? Okay, so I have a t and a t, and I have a positive 21 here, which means that these signs are either both positive or both negative. Since my middle term is negative, that means they both must be negative. And that also means that I'm looking for two factors of 21 that add to 10. What do you think? 3 and 7, good. It doesn't matter which one we put where because they're both negative. Okay, and so now that I've got that fully factored, I analyze each one of my factors to see if they could equal 0. This first factor here, this cannot equal 0 because there's no variable in it. So I don't worry about it. This second factor, if t were equal to a positive 3, this second factor would equal 0. So that's one solution to this problem. T minus 7 factor, if t were equal to a positive 7, this would also equal 0. So the two solutions to this particular problem are t equals 3 and t equals 7. Let's go back up. It turns out that both of those solutions make sense for our problem. This problem says that we will have 210 micrograms of epinephrine in the bloodstream 3 minutes after injection, and then 7 minutes after injection. So if you're wondering, what? How does that work? We got to look at a graph. This is a graph of that particular function. And so you'll see the way that this works is that at point 0, the patient has 0 micrograms in their blood. Right? After they give the injection, the microgram level starts to rise, and eventually it passes 240. I think that's what they wanted, 240. And it passes 240 at 3, right? Bing. Once it goes over 240, then the amount of epinephrine in the blood starts to decrease. And we go past that mark one more time after 7 minutes. So that's why we had two solutions for this one problem, because it actually happens twice. Any questions on that? By the way, this might be helpful for you guys. And use it for only good purposes. Don't use this for evil. You can graph any function you want in Google. All these polynomials that we're working on, you can say graph, right, space, and then suppose I wanted to graph something simple. Suppose I wanted to graph x squared. That little caret symbol up there, that's computer code for squared. right? That's how you enter a squared in computer code. And so that's how you do it in Google. So I want maybe x squared, let's say,
I thought it was computer speak for X.
sorry, not squared, exponent. Yeah, the caret symbol means you're accessing that upper exponent. Thank you for that. So then the second term, let's just say that is plus 5x. And then let's just add 1 to all that. There we go. This will draw a graph for me. It might not be helpful in every problem, but especially if you're like, you know, especially next year when you're graphing stuff and you want to check your work, this is one way to do it. Or to interpret some of these problems. You might run into some of these problems like the medication one and think, why do we have 2 solutions? I don't quite understand that. Well, you can punch it into Google and just say graph, and it'll tell you exactly what that looks like. One more thing that you can use it for, even though this is a little bit nefarious, you can try and see what the zeros are from this graph, and so you can tell what to factor it into. But it's not exact, so I'm gonna know you're using Google if you have like, you know, 0.0543 that you factored into. You're like, what? No, I don't think so. So anyway, that's a little tool you can use. Moving on to the Pythagorean theorem. Yay, yay, yay. So this is the Pythagorean theorem. It's in your book. I would definitely put it on your note card before the next test. The Pythagorean theorem, all it says is it just creates a relationship between the legs of a right triangle. And it basically says, if you take the squares of these 2 legs that are attached to the right angle, and you add them together, they will equal the square of this hypotenuse. That's it. So we'll learn how to apply that in a couple of different situations. All right, so the first one is going to be bridge design. This one's a little bit weird. Man, they explained this one in a strange way. So I went ahead and included the picture of the diagram here. So they say a 50-foot diagonal brace on a bridge connects a support under the road surface at the center of the bridge, this diagonal here. The horizontal distance that it spans is 10 feet longer than the height that it reaches at the center of the bridge. Find both distances. Okay, so let's zoom in a little bit. This is my triangle that I'm looking at here. And so basically the Pythagorean says, if I square this and I add it to this squared, it should equal this hypotenuse squared. So I'm going to go ahead and do that. So I have my first leg, x squared. My second leg is x plus 10, so I say plus x plus 10 in parentheses squared equals the hypotenuse squared. I just created a polynomial. Now I go ahead and solve this guy. So to solve this, the first thing we need to do is FOIL out this x plus 10 squared. So I have my x squared out front that kind of just hangs out. And when we FOIL x plus 10 squared, we end up with x squared plus 20x plus 100. That was a perfect square trinomial. That's why I didn't stop to FOIL anything out. Because if you memorize the perfect square trinomials, you can do that too. All right, so 50 squared, what is that? That is 2,500. All right, so now I want to combine everything and set it equal to 0. So on my next line, or on this line, I'm going to go ahead and subtract 2,500 from both sides. All right, so now I have 2x squared plus 20x minus 2,400, and that equals 0. All right, so like I always do, I'm going to take a look at all these terms and see if there's something common I can factor out. There definitely is. I can at least factor out a 2. So I'm going to do that. So I have x squared plus 20x minus 1200 now. And that is equal to 0. Okay. Thank you. Big mistake. Big mistake. So I forgot to cut that 20x in half. I'm just checking to see if you guys are paying attention. I'm watching you guys. All right. Oh, I got a cramp in my side. Sorry. This is how out of shape I am. I'm cramping up. All right. So now we got to factor this guy, right? Okay. So the 2 out front stays the same. All right. We see that there's no coefficient on the inside, which means this is a basic factorization. Splits up into 2 brackets. Each one start with an x. I have a negative term here, which means I have a positive and a negative in here, and it means that I'm looking for a difference. I'm looking for 2 numbers whose product is 1200, but their difference is 10. 1200 sums 10. You see it? Right? Is it 100 times 12? No. Not really. What else could I use? There's divided by 50. Let's check. 1200 divided by 50. That's 24. So 50 times 24, that's not going to give us what we want. Those differ by 26 instead of 10, which is what we want. What can I use? I see people guessing and checking out there. Good, good.
40.
That is an excellent guess. So let's see now. 1200 divided by 40, that equals 30. I like it. So I have 40, I have 30. Which one should the negative sign go on? Yeah, the 30, because my middle term is a positive 10. So I want my overall result to be positive when I add these two things together. So I have 40 minus 30. That equals 10. These are the numbers I'm looking for. So I fill it in. Negative 30, positive 40. There we go. Now I analyze each factor for a possible 0. This first factor is not really important. It can't be 0. My second factor, x plus 40, this would equal 0 if x were equal to a negative 40. This factor here, x minus 30, that would be equal to 0 if x were equal to a positive 30. Since we were dealing with distance, we can just consider this negative answer not correct. So now we have an x equals 30. We can draw the dimensions of their triangle. We have a 30, 40, 50. Any questions so far? Yeah, it's sort of formulaic the way that you do this. You know, you just recognize what problem type it is. You think of an associated formula. Some of them are area, some of them are consecutive numbers, and then you fill it in and solve. That's about it.
Doing hypotenuse stuff pre-algebra, but I don't remember any polynomial factorizing.
Yeah, this is something, I think this is something that's new to this class, that you start doing the polynomial factorization and the Pythagorean. But definitely in your next class, you'll be doing a lot of it too. Okay. So, you guys have seen me do a couple of triangle problems. Why don't you guys try this one on your own? All right. So, remember, the area of a triangle, A, is equal to 1/2 base times height. So this problem says a triangular traffic island has a base that is half as long as its height. Find the base and the height of the island if it has an area of 64 feet square. You guys are stuck on that first step, which is usually where it happens, especially the first time you do it, right? The first step, you might say, well, I know that for this particular formula, base is equal to this number, 1/2 h. And then you might plug this in here. So you might say A is equal to 1/2 times 1/2 h times h. So that might be how you start that problem. Then, of course, they give us a value for capital A, don't they? Okay, take another couple minutes. Okay. So, as we went over a couple seconds ago, the main formula that we start out with is just the area of a triangle for this one. And we slowly fill that in. So they gave us a value for the base. That was exactly 1/2 of what the height was. And we went ahead and plugged that guy in. Then in the next step, we did our math on what we plugged in, and we also plugged in the area equals 64. And so now we can solve this. So I'm going to subtract 64 from both sides so I can have everything equal 0. Minus 64, minus 64. And that leaves me with 1/4 h squared minus 64 equals 0. So now, because I don't like fractions, especially when I'm factoring, I'm going to go ahead and multiply through by something that'll clear this fraction, right? And as you guys may have noticed right now, if you have a fraction, multiply through by the denominator and it'll clear that fraction. Okay, so I'm going to multiply through by 4. All right, on this side, when I distribute the 4, they both cancel, and I just end up with h squared. When I distribute my 4 into the 64, I end up with negative 256. And that is equal to 4 times 0, which is just 0. So now I'm in that classic situation where I have a negative sign in the middle, right? I have two terms, so this might be a difference of squared. So what I want to check, I want to see if there's an even square to 256. It's 16. So this is just equal to h plus 16 times h minus 16. All right, and my two solutions that I can pull out of these two factors are h is equal to plus or minus 16. Right? And I skipped a step there. These are just the two numbers that would turn these that would turn these factors into zeros, right? All right. So I don't think I actually needed the negative version of the 16 since we're talking about height on this one. So I'm just going to erase that. Only the positive 16. So they say find the base and the height of the island. So I'll just draw my little diagram here. I will say my base is equal to, I don't know because I already forgot my solution, 16. So height is 16 and base is 1/2 height, so base is 8. All right. So remember how we did that, right? On a lot of these, unless they give you the polynomial in the first place, this is kind of how you do it. You get your general formula and you plug things into that general formula. All right. So let's talk about maybe one more example here. So here we are, Dovetail Woodworking. They determined that the revenue R in thousands of dollars from the sale of X sets of cabinets is given by this function. This little symbol right here, sorry, they shouldn't put this in there. This is read R of X. That's kind of a weird problem. Equals 2x squared plus x. If the cost C in thousands of dollars of producing X sets of cabinets given by C equals x squared minus 2x plus 10, how many sets must be produced and sold in order for the company to break even? Okay, so they said this R, this is revenue, right? Cost, that is C, right? And so when we talk about breaking even, right, that means that the cost and the revenue are equal, right? That's what it means to break even, right? And so we can say C equals R. That is sort of the gist of what we're doing here. We're saying when does C equal R? So basically we set these two polynomials equal to each other and we black out the answer that we forgot to earlier. Okay, so I have C, right? C is equal to x squared minus 2x plus 10. R, that one's equal to 2x squared plus x. Now all I need to do is combine all my terms and solve these things. Yeah, I guess I'll just subtract everything that's on the right side. So I'm going to say minus 2x squared minus x. And then over here on the left side, I end up with minus 2x squared minus x. All right, so everything on this side cancels. And then on the left side, we end up with a negative x squared minus 3x plus 10 equals 0. So my leading term, I don't like that to be negative, so I'm going to go ahead and factor a negative out. What I have left is x squared plus 3x minus 10 equals 0. All right, now I just need to factor what I have on the inside here, and yeah, we can do that here. So I don't have a coefficient out front, so this is a simple version of factoring. So I just write out my brackets, right? Good. We have x's here and x's there. Somebody's already got the factor vision, which is good. That's excellent, right? We see our last term is a negative, and so we have a positive and a negative in the middle here. And we say we're looking for two factors of 10 that differ by this middle term, 3. Right? And yeah, somebody's got the factor vision out there, which is awesome. It feels good to get that. So we have a 5 and a 2. Which of these should go on the positive? Oh, did you? I was thinking 7 and 3, but no, it's 5 and 2, right? Because 5 times 2 equals 10. Yeah, and so I'm sorry. I think I might have had a brain fart when you said that. Yeah. My apologies. So yeah, we're looking for two things that multiply to give us this last term, which add to give us the middle term. And since this is a negative number, we're actually looking for a difference instead of an addition.
7 and 3 are factors of 10. What's going on?
I actually did like 7 plus 3 and then 7 minus 3. But I don't know. Never mind. Never mind.
All right. So the two numbers are 5 and 2, without a doubt. Since we need a positive 3 in the middle, we're going to put the 5 on the positive and the 2 on the negative. All right. And so then to finally solve this guy, we say this first factor, that equals 0 when x equals negative 5. This second factor, that equals 0 when x equals a positive 2. So we go back up to the original problem, and we find that negative 5 doesn't really make sense, so they have to sell 2 cabinets to break even. All right, so we're going to skip this last problem because it's long. All right, any questions? Thank you very much for your patience today. My apologies for all the mistakes. Yeah, I'm glad you guys all had a good spring break, though, even if it destroyed your mathematics.